Today we're going to be explaining how to find the change in temperature in a specific heat capacity. The specific heat capacity for water is about 4.184 joules per gram per Celsius. So what does this mean? If we have 1 gram of water, then it requires 4.184 joules to heat up this 1 gram of water by 1 degree Celsius. So now using this, we can therefore define what is specific heat capacity. The energy needed to raise the temperature of 1 unit of mass, like 1 kg or 1 gram, of a substance by 1 degree or Kelvin, acting as a measure of how much heat a material can store before its temperature rises. So now let's look at the specific equation that we can use for specific change in heat capacity, which is Q equals to mc delta T. M is mass in grams, and C stands for joules divided by grams per Celsius. And then we have change in temperature, which is usually Celsius. So when we put all of this together, we can always cancel out the Celsius and we can always cancel out the grams in order to get Q, which is joules. Delta T is the final temperature minus the initial temperature. But to look for our specific topic, we have to look for delta T, which will be explained
if 100 grams of water
100 grams with a specific heat capacity of 4.18
joules per gram degree Celsius
per
loses
232
what is the
joules of
change
heat.
in temperature?
What is the
first thing
change
that you're
in
going to
temperature?
want to do
So
is
firstly,
write down
what
your
we want to
formula.
do is write down
Q
our
equals
formula, which is Q
MC
equals to
delta
MC
T.
delta T.
And then we want to start
So now let's go ahead
substituting
and substitute the information
from our problem
into our
the formula. So if 100 grams of water, so our mass is going to be 100 grams
of water. Then the specific heat capacity will be 4.18 joules per gram per Celsius. Then our Q will be 232 joules of heat, since the water loses 232 joules of heat. And what is the change in temperature? So now we're going to solve for delta T. So the first thing we'll want to do is 232 joules equals to 100 grams times 4.18 joules per gram per Celsius, which would then give us 418. What we're doing here is isolating the delta T. So now let's go ahead and cancel out the 418 in order to isolate it completely. Now that delta T is by itself, we're going to go ahead and divide the 232 joules by the 418. So that would then give us 0.56 degrees Celsius, where all of the units will be cancelled. So our final answer is delta T equals to 0.56 Celsius.